Okay, we have this JAMB question before us under convex mirror. Now the question says, the driving mirror of a car has a radius of curvature of 1 meter. A vehicle behind the car is 4 meters from the mirror. Find the image distance behind the mirror. Our solution. Now the first question we'll ask ourselves is, what type of mirror is this? And of course, this is a convex mirror. A driving mirror is a convex mirror. And of course, you know that a convex mirror produces a virtual image. Now the image produced must be minus. Now the focal length is negative. So whatever we are going to get will still give us negative. Now let us x-ray the information given to us here. Now the radius of curvature R, radius of curvature is 1 meter. Of course, the relationship between radius of curvature and the focal length is that R is equal to 2F. Therefore, F will give us 1/2. Now the focal length now is 1/2. Because this is a convex mirror, it will now give us minus 1/2. Please, for full lesson on convex mirror, why F is negative and V is negative, please see the link in the description below. Let's continue. The next one is, they said a vehicle behind the driver, behind the mirror, and of course that vehicle serves as the object. Now the object distance is 4 meters. Find the image distance. Image distance is what we are looking for. Now at the end of the day, we must get one of these options, and one is correct, the others are wrong. Now the formula we apply will now give us 1/f is 1/u plus 1/v. This is the entry. Now, because we are looking for v is expected to be negative. Because we are looking for v, we'll leave it at positive, because if you use negative, at the end of the day you get positive. So we use positive so that at the end of the day we'll have a negative. Now f is minus, so we now substitute by writing minus 1/2. F is half. So minus 1/2 is equal to 1/u. U is 4 plus 1/v. V is the unknown we are looking for. Now we move. This is inverse 1/2, and of course inverse means turn upside down, which will now give us, if we invert this, the other of this will now give us 2/1, or just 2, we can have write 2, but for the benefit of doubt we'll have 2/1 is equal to 1/4 plus 1/v. At this point we'll collect like times. This one should go over here. Now if it goes over there, remember please, there is a minus here. If this one goes over, the sign will change. So we now have minus 2/1 minus 1/4 is equal to 1/v. Now we can add here, we can subtract here. If we subtract here, we take the LCM of 1 and 4. LCM of 1 and 4 will give us 4. So we have 4 here. 1 into 4 will give us 4. 4 times minus 2 will give us minus 8. Now you return your minus here. 4 divide 1. Sorry, 4 divide 4 will give us 1. 1 times 1 will give us minus 1, which will give us minus 8 minus 1 will give us equal to minus 9/4. Remember, this is everything is equal to v, please. This is equal to 1/v. Now let 1/v the subject. 1/v V is equal to 9 over 4. Now, this is inverse of V. We are looking for V. What do? It's that you cross multiply V times 9 and then 1 times 4 to get V. But for the want of time, 1 over means inverse. Inverse means invert this side. So if we invert this, we now have that V is equal to 4 over 9. At the end of the day, remember there is minus here. But because from the question there is no minus, so we just drop the negative sign and put the correct one. Now the answer will now give us option B. Please like this page, share this video, and then follow for more. Second question, and this question says, a dentist obtains a linear magnification of 4 of a hole in a tooth by placing a concave mirror at a distance of 2 cm from the tooth. The radius of curvature of the mirror is dash. Now the radius of curvature must be one of these options. Solution. A dentist obtains, of course, the mirror that is used here is concave and not convex. Concave mirror produces the V is always positive and F is positive. Sorry, V most time, depending on the position of the object, is either V or U, or is either positive or negative. But F is always what positive for a concave mirror. Still see the full lesson on the description below. The link is on the description. Now we have the magnification here obtained is 4 by placing a concave mirror at a distance of 2 cm from the tooth. That means the tooth is serving as the object. So the distance between the tooth and the mirror is object distance. Object distance U is 2 cm. Radius of curvature. And of course, V, there is no V. V is not there also. Now for us to get the radius of curvature, recall that radius of curvature R will give us 2F. So whatever we get, whatever we get as our F, we'll multiply it by 2 in order to get our radius of curvature. So we take note of this. Okay, now we have, for us to get V, we have U already, we have V, and we have M. First, get V using M and U. Now using the relation that says M is V over U. You substitute into this. When we substitute into that, we have that our M is what? 4. V is unknown, and U is 2. So we have 4 is equal to V over 2. Now V will give us 4 times 2. Therefore, the image is 8 centimeter. The image distance. Having gotten our image distance, our U, we can now proceed to get F. We can proceed to get F. Now, there is no F there. So, we can use the 3 to get F using the formula that says 1 over F is equal to 1 over U plus 1 over V. Now, we can have 1 over F. We look for F first. 1 over F is equal to 1 over U. U is 1 over 2. 1 over 2 plus 1 over 8, which will give us 1 over F equals, the LCM of 2 and 8 is 8. 2 divided 8 will give us 4. 4 times 1, 4 plus 8 divided 8, 1. 1 times 1, 1. Which will give us 1 over f is equal to 4 plus 1 will give us 5 over 8. Now, f will give us 8 over 5. 8 over 5 will give us 1.6. Now, the focal length is 1.6 cm. But the question says, what is the radius of curvature? Now, we recall this relation that says r is equal to 2f. Therefore, the radius of curvature is 2 times 1.6. Radius of curvature will now give us r will give us 1.6 times 2, and it will give us 3.2. But of course, 3.2 is option B. R is 3.2 centimeter, and this is radius of curvature. Please feel free, share this video to as many as you can. Give it a like and then follow for more. Thank you.